Hello buddies, how are you all? In this session, we will cover the chapter Work and Energy, Class 9 Science. So, without further wasting time, let's get started. So, in this whole session, we will cover the topics work, energy, law of conservation of energy, and power. So, when can we say a work is done? When a force acts on an object and the object slides or covers a distance or displacement in that direction, then we can say a work is done. So, what are the conditions? A force should act on the object must be displaced, and the direction of the force must not be perpendicular to the displacement. This last point is much confusing to you, but it will be soon very clear to you. There is definition of work. A work can be defined as the product of force and displacement. So, here you can see that the man is trying to push the panda in this direction by putting force F, and the panda slides here and covers a displacement S. So the formula comes out as work equals to force into S into cos theta. This cos theta is not in your book, but it will surely help you to understand the formula. So there is an angle between force and displacement. There is the angle 0, means they are parallel. So cos 0 equals to 1. Trigonometric table. Here cos 0 equals to 1. So the formula comes out as work equals to force into displacement into 1. Means work equals to force into displacement. Now in this image you can clearly see that the man is trying to push the panda in this direction. It is not parallel and not in the opposite direction, but there is an angle between them. The angle can be said as theta. So the formula comes out as work equals to Fs cos theta. You will put the angle and you will get the answer. There are a few important points related to work, like the SI unit of work, the CJS unit of work. There are joule and arj respectively, and there are few angles like theta 0 means cos 0 equals to 1. Here cos 0 equals to 1. Here cos 0 equals to 1. And here theta equals to 90 degree means work equals to 0. Here theta means here but theta equals 90 degree here. Now I think the point is very clear in the first when I say now if the force is perpendicular, then the whole work will be 0. Here force into displacement into 0 equals to 0. And in theta when 180 degree, here in 180 degree it is minus 1. So cos 180 equals to minus 1 and work equals to F into S into minus 1 means minus F into S. So if you understand the earlier concept very clearly, then it will be very easy for you to understand this concept of positive and negative work. When angle between the force and displacement is acute angle, means the angle is greater than 0 degree and less than 90 degree, the work done is positive. Here you can see that the angles which are greater than 90, less than 90 degree are positive. And when the angle between the force and displacement is obtuse angle, means it is greater than 90 degree and less than 180 degree, the work done is negative. And here you can clearly see that the angle which is greater than 90 degree means 180 degree is negative. And you think the work is over, but there is another concept of zero work. Means you already know about the zero work. Here about the perpendicular, the cos 90 equals 0, you know this. But there is also two conditions like net force equals to 0 and the net displacement equals to 0. Then here if net force equals to 0 means this F equals to 0, and when this S equals to 0, then the answer will be 0. Now we will study the concept of energy. Energy can be defined as the capacity to do work, and its unit is as same as the work unit, means it is joule. There is a large unit of energy like kilojoule, it is kJ, and 1 kilojoule equals to 1000 joule. Remember this, it is very important for your exam. There are different forms of energy, but in this session, means in your syllabus there is only mechanical energy, and in mechanical energy there are two types of energy, kinetic energy and potential energy. So, first, kinetic energy. Object in motion possesses some energy and can do work. This energy is called kinetic energy. Means a object is in motion, and in motion there is an energy called kinetic energy. So, from scratch we will understand how the formula gets half mv square. So we know F equals to ma, means mass into acceleration, and we also know work equals to force into displacement. Don't remember the cos theta, it is out of box. So from the second equation of motion we know that v square equals to u square, v square minus u square equals to 2as. So rearranging the equation means eliminating the s to the left side, or rearranging the equation we will get s equals to v square minus u square by 2as, and work equals to, means work equals to F into s. So F here comes as ma, and s here comes as v square minus u square by 2as here. So the work equals to ma into v square minus u square by 2a. So taking the initial velocity as 0 means u equals to 0, kinetic energy equals to half mv square. So I think it is very clear to you. So in the image you can clearly see that the panda is in motion, and the kinetic energy is in this direction, means downward direction towards the gravity. As the center of the earth, it is pulled by the gravity. So there is another concept. When two identical bodies are in motion, the body with higher velocity has more kinetic energy. Here you can see the panda is same, but the velocity are different. The velocity here with parachute is much lesser than the free fall. So you can clearly see the panda is scared, and the kinetic energy is much larger here in this condition. So there is a theorem called work energy theorem. The work energy theorem states that the net work done by a moving body can be calculated by finding the change in K, means by subtracting initial kinetic energy from the final kinetic energy, means work net equals to K final minus K initial, and work net equals to half m here v square minus u square. So there are some factors affecting kinetic energy like mass, velocity, momentum, and you know that momentum on a p, here p equals to m v. So here you can clearly see that is m and v. Next we will study about potential energy. There is a definition. The energy that is possessed by a body by virtue of its configuration or change in position is known as potential energy. So in simple words, if the body is in rest and it has come to in rest by some change in position, then we can say that it has potential energy in it. The energy can get stored in an object when work is done on it. Means, for example, stretching the string of the bow by an arrow. In this example, the potential energy is stored in the bow in form of elastic potential energy. Means this energy. Potential energy, gravitational, chemical and elastic. First we will say about elastic. Energy stored when object is stretched or compressed. Means chemical potential energy is energy stored in the bonds of atoms and molecules. This gravitational potential energy will be very clear to you after some time. Here, the potential energy of an object at a height. This is the gravitational potential energy. So, when an object is raised to a certain height, here you can see the panda is raised very high from the city and is hanged by a flamingo. So here energy is stored as potential energy. If the hand gets loosened, then it will directly fall and will have kinetic energy in it. So there is stored potential energy. So work equals to force into displacement, F equals to ma. So there is MAS. In the direction of increasing the height, F equals to ma and A equals to g. So therefore work in potential energy is equals to mgh, and change in potential energy minus mg, here h final and minus h initial, here this h, change in potential energy if we try to find. Then there is a law of conservation of energy. Means law of conservation of energy states that the energy can neither be created nor be destroyed, but can be transferred from one form to another. The total energy before and after the transmission remains constant. So here you can clearly see that it has potential energy in it and this has kinetic energy in it. So potential plus kinetic is always constant. So mgh plus half mv square equals to constant. For example, consider a panda falling freely from a height. At height h, it has only p potential energy mgh. So by the time it is about to hit the ground, it has a velocity and therefore has kinetic energy, half mv square. So therefore energy gets transferred from potential energy to kinetic energy, while the total energy remains same. Now we will study about power. The rate of doing work or rate of transfer of energy is called power. Means work by time equals to power. At how much time the work is done. The unit of power is watt, or it is joule per second. The average power is total energy consumed by total time. Commercial unit of power is kilowatt, and 1 kilowatt equals to 3.6